So anyway, this is the intro to oceanography module. So there's basically 4 different types of oceanography. There's geological oceanography. There is chemical oceanography, physical, and marine. The geological is going to talk about the shape and the geological features of the ocean floor. You're probably going to do a little bit of plate tectonics in geological oceanography. Let me add plate tectonics here. But it's going to, when I think geology, I think rocks. So if it's rock-ish, it will probably be in the geological section. That's just my, how I remember it. Even though that's not a very precise definition. Just in general, if you're trying to figure out, what something belongs in. Okay, this is not liking my pen today. Chemical oceanography is going to be like seawater composition, the biochemical cycles. So examples of the biochemical cycles, because I noticed this was on a couple of people got confused a little bit with this on the worksheet we did. The water cycle is a biochemical cycle. Another important one we talk about is the nitrogen cycle, the carbon cycle. The phosphorus cycle is big on land, but we're not really going to mess with that in the water too much because, it doesn't, it's not huge in the water. Basically the water, the nitrogen, and the carbon, and then maybe the sulfur cycle. Those will be the few that will really, the main ones that you look at. Physical oceanography is going to talk about temperature, density, pressure, wave characteristics, tidal forces, basically things that you might think of in like physics, right? So chemical is going to be kind of like chemistry, which is kind of nice. They kind of sound the same. Physical sounds a lot like physics. So it would be, the physics side of basically physical science or, physics-y kind of things. And then my favorite section is marine, and that's the study of plants and animals, including their life cycles. So that's the part I really like. And in the fall, we'll focus on these top 3. And then in the spring, we'll do a lot with the marine. So I know a lot of y'all said in your welcome session that you were really excited about, learning about animals and things like that in the ocean. That'll be kind of in the spring. We'll use the fall to kind of like prepare and learn about kind of almost the background of the ocean. And then we'll be able to more understand why the animals in the ocean are the way they are because, they have to live with these, geological, chemical, and physical features of the ocean. It's like we're stuck in a loop or something. It's only showing the first 2 slides. That's no good. Okay, here we go. Excellent. Okay, so this is the end, though. Oh, no. Okay, let me see if I get out of the annotation tool, if it will work. Phew. Okay. So the basins of the ocean. These are our big 5 oceans. The Pacific, the Atlantic, the Indian, the Southern, and the Arctic. The Pacific is by far the largest. You can see, let me see if I do an annotation, if it's going to take this away. Oh, it is. Okay. We won't do that then. Okay. So the Pacific Ocean, you can see if you look at the second column, the area, the square miles, it's almost like double the size of the Atlantic Ocean, which is the next largest ocean. So it's definitely the largest. And then it's showing like the deepest part of those oceans. So the Mariana Trench is the deepest part of the Pacific Ocean. The Puerto Rico Trench is the deepest part of the Atlantic Ocean. The Java Trench is the Indian. The southern end of the South Sandwich Trench in the Southern Ocean is the deepest part of that ocean. And then the Eurasia Basin in the Arctic Ocean is the deepest part of that. But overall, the Mariana Trench is the deepest part of the ocean. And what you'll notice, if you were to look at a picture of these trenches on a map of like the plates of the ocean, you'll see that they're usually where plates come together or move apart, however you want to say it. And that's usually where those trenches are. So let's go to the next thing. Okay, so now we can see the depth. This was in your content, which I thought it was a really cool map. It's showing the shallowest is the red, and then it goes to green, and then blue is the very deepest. So interestingly, it has like it has the land as being green, and then you'll see basically all of the continental shelves basically outline the land. If you see those, all that red, that's basically the continental shelf, and it's kind of outlining, you know, that's the shallow part. So that part, you know, it doesn't really get very deep compared to the rest of the ocean, although it may seem deep to us, you know, not necessarily we can touch the bottom, you know, on the continental shelf. But a lot of times, too, the continental shelf was places where when the ocean, the sea level was lower, the continental shelf may have been exposed. And so that's kind of part that kind of ebbs and flows sometimes with the different height of sea level. You can see here, usually, again, the very deepest parts are kind of in the middle. But anyway, I thought it was pretty cool. And it's just so you guys know, if you look at this map, you'll notice the United States is on the right of the map, not the left. So it's centered on the Pacific Ocean. So you might be looking at it trying to get your way around this map. Australia is kind of in the middle, and then the United States is on the right, just so you guys kind of see that. And then the very, very left, you can kind of see Africa. Okay, so let's talk about the history of these oceanographers. John Cook was an explorer. He was the first to map the eastern coastline of Australia, discover the Hawaiian Islands, map Newfoundland and New Zealand, and first to circumnavigate the globe. So they give him the honor of being the first ocean scientist. So that's his honor, or his, you know, claim to fame, I guess. John Harrison built a chronometer, which determines your longitude, which honestly, that was the first for me. I have never used a chronometer as far as I know. Maybe it's in a GPS. Matthew Maury is a naval officer. He's the first to use worldwide patterns of surface winds and currents. And so they call him the father of physical oceanography because, again, winds and currents, those are kind of things that you study in physical oceanography. Charles Darwin, you know, we usually think of him as that evolution guy, but he did, you know, go on a really long boat trip, right, the voyage of the Beagle, where he went to the Galapagos and all of that. So not only did he kind of come up with the idea for evolution on this trip, but he also, you know, studied the ocean a little bit. And he basically discussed how atolls and reefs grew from the sea floor. And he did the longest continuous oceanographic study at that time because, you know, he was on that voyage of the Beagle for so long. And then the HMS Challenger was the very first purely scientific oceanographic expedition. And so it really established oceanography as a science. Before then, it was kind of like a sidebar, you know, to other things that people were doing. But it, you know, it really established it as its own science. So that's kind of cool. So let's talk a little bit about living resources in the ocean. This is just going to be a big overview. Again, we're going to talk a lot about this in the spring. So the big living resources in the ocean are obviously seafood. And we catch seafood in, we call them fisheries. That's the process basically in the business of catching seafood. And the big thing about fisheries that's really important is that we are continuously overfishing the ocean. We are catching too many fish. So if you look at both of these graphs, let me see. I really want to annotate this. So I'm going to try again and see if it'll let me. No. Okay. That's so weird. Okay, so if you look at the end of these graphs, like all the way on the right side, you can see For the first graph with the red line, you can see that it's just going down, 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 down. You know, in the 60s and 70s, we get super good at catching fish, and that's one of the problems. Our technology is getting so good that we can catch so many fish, and the fish, you know, they can't adapt to that technology or whatever, and they just can't do it. And so we catch too many, and then there's not enough of them to reproduce, and we're still catching so many, and then, you know, the fishery collapses. That's what they call it, when you basically can't catch enough fish of that fishery in order to make a living anymore. They say that fishery has collapsed. If you look on the right graph, you can see again in the 60s and 70s, they're just going crazy catching so many fish. You see how high that is. And you can see before that, it was basically relatively constant, going up a little bit, but basically relatively constant. So we're taking fish out, but we're not taking too many out, and the fish can repopulate from that loss. But then the 60s and 70s, we get this new technology, and it's just totally decimating their population. And if you look at 1992, you can see that line totally fell off the graph. There's literally no line there, because there's just, and even in the 2000s, you can see the line is just barely above zero. There's just hardly any fish left to catch. And so, obviously that's a huge problem. So one of the things that like fisheries managers do now is they kind of keep track of how much fish are being caught, and then in order to avoid a fishery collapse where then nobody can catch any fish, they kind of set catch limits on the fishery, and they'll say, oh, you can catch this many fish this year or whatever. And so a lot of folks get upset with these catch limits, but they're really important actually to preserve that fishery for the future. And so everybody can keep catching fish, and we don't just, completely fish it into the ground and then there's nothing left for anyone. So that's the big overall picture of what's going on with these living resources. Our non-living resources, you might not think about it, but water is actually, a resource in the ocean. Even though it's salty, we can actually desalinize that water. They call it a desalinization plant. And they can basically remove the salt from the water and make it fresh water. You can get natural gas from the ocean. And then you can get all sorts of minerals from the ocean. I'm sure you've seen like the BP oil spill that was, I guess it was a long time ago now. But that was in the Gulf of Mexico. They were getting oil out of the bottom of the ocean. But you can get all sorts of different minerals and things from the ocean. So these are our main non-living resources that we get from the ocean. And that's basically the gist of that Intro to Oceanography module. I still really recommend that you read it in the course, but I just kind of wanted to give you guys like the broad overview picture, kind of wet your whistle a little bit about what's going on in that module, and then you can go in and kind of read the details. So that's kind of what I have for oceanography students. If you have any questions, I would love to answer them for you.